Hey there again. I thought you'd like the title of this one. I couldn't think of a good one, and nothing came with the book, so I decided that I was just going to call this little section Throwing Things, because it really has a lot to do with projectiles. And that's kind of when you throw something or fire a gun or shoot an arrow or something like that. So there is a general equation for it, and it is, and it kind of splits right here, so I don't like that. But it basically says h of t, and I'll explain that later, equals negative 16t squared plus v sub 0 t plus h sub 0. Yeah, I understand. So what this is saying is that the height of the thing that we're throwing at any particular time is negative 16 times the square of the time plus the initial velocity. That's why it has the 0 there. So the velocity, the force that it was thrown with, times the time, and plus the initial height of where it was thrown. So this v0 and this h sub 0 are constants. They're not going to change in our situation. So this is all basically saying that the height of whatever we're throwing is going to change depending on how many seconds after it was thrown. It's a little bit confusing, so let's look at something that's going to be a little bit more concrete. And I never know which color to use for this dark background. So let's say, okay, so our friend Sandra throws an object straight up in the air, and she has an initial velocity of 38 feet per second from a platform that is 30 feet above the ground. We're going to use that formula and want to find out how long it will take, how many seconds will it would take for the object to hit the ground. So she's throwing something up in the air, then it needs to turn and come back down to the ground. So we're going to let t represent the number of seconds after the object was released. That's how t was actually defined in this formula. So we are going to let h represent the height of the object t seconds after the object was released. So that's why the h of t exists. So the height depending on how many seconds. So the big question is, what is the height of the object when it hits the ground? I know that's not what we're trying to find out. We're trying to find out how long it will take. But what is the height of the object when it hits the ground? Think about this in terms of maybe sea level. When somebody's above sea level, they're at a positive number. When they're below sea level or underground, got a negative number. When they're at sea level or on the ground, our height is 0. And we want to know which part of the formula represents the height of the ball after a certain number of seconds after being released. So, and that's just so we can understand what's in this formula. That's the h of t. That represents the height at a certain time. Okay? And so they gave us our v0 and our h0. So we just need to plug those in and solve our equation. So I think I made another copy of this slide so we can have a little bit more space. Yeah, I did. So I'm going to take this 38 here. That's the velocity. So that's going to go in for v sub 0. And then this 30 feet, that's above ground. That's where the thing Sandra started. So it's kind of like Sandra's standing on a platform that's 30 feet up in the air. And here's Sandra. And so she throws the thing, and then it comes back down, and here's the ground. So that's why our ground is 0. So we want to know what that height is. We want to know what t has to be so that h sub t equals 0. So we're finding the roots, or the zeros. So we're going to start by saying 0 equals negative 16t plus 38t plus 30. Okay. Now our decision tree. Is that easily factorable? No. I'll tell you that right now. I did factor it. It was horrible. At least I think I did. And it really was horrible. So I don't suggest doing it. Is B an even number? Yeah, B is an even number. So I could take half of that, which is 19, and then square that. Well, at first I'd have to move that 30 over and square it. And 19 squared is 381. So I don't want to deal with those big numbers. So even though we could complete the square, and I might show you what that might look like, I want to use the quadratic formula. Because I just think it's going to be more straightforward than having to play games with that 981 number. No, 381. Sorry. So, going to use the quadratic formula. And we always start it with x, but even though our x really here is going to be t, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I can never start that out right, but I get there by the time we get to the square root. Okay, so plug and chug. Our b is 38, so we start with negative 38 plus or minus. Oh my, 38 squared? I'm going to say calculator time. 38 squared is 38 times 38. 1444 minus 4 times a, which is negative 16, and c, which is 30. All over 2 times negative 16, because that's a. Oh, calculator's going to get a workout, I believe. Let's start by doing that big multiplication under the radical. We've got a negative 4 times a negative 16, so that's going to cancel each other out, become positive. That's nice. 4 times 16 is 64 times 30. So it's going to be 1444 plus 1960. It's going to be 3364. So that's going to equal negative 38 plus or minus the square root of 3364 all over negative 32. Yuck. Oh, yeah. Maybe completing the square might have been easier. Can we figure out the square root of 3364? Yes, thank goodness. It's 58. So that's nice. So we're going to have, continue over here, negative 38 plus or minus 58 all over 32, negative 32. And so now I can split this up into our plus 58 part and then our minus 58 part. So let's see, negative 38 plus 58 over negative 32. Ooh, that's going to be 20 over negative 32. Over the second way with negative 38 minus 58 over negative 32. Negative 38 minus 58. It's going to be 96. So that's negative 96 over negative 32. Now that's a positive number. 96 divided by 32. 96 divided by 32, that's 3. I know, all these arrows are going to be really hard to follow. I'm really sorry. Okay, so I've got here a negative number. Over here, but a negative number would mean, because we're talking about time, would mean that it would land on the ground before she threw it. And I don't think that makes sense. Well, you may think it makes sense. I don't think it makes sense because I don't think we have invented time travel yet, although that would be really, really cool. And here we have an answer saying that the ball, I assume it's a ball, landed on the ground 3 seconds after she threw it. So I think we're going to go with that. So we're going to say that basically t equals 3 seconds. And we can check that out by substituting and plug and chug into the formula, but I will leave that up to you. So we have one more example to look at, and that is going to be about dimensions changing when the area changes. Before we looked at area changing when the dimensions changed. So now we're just going to look at it backwards. So I'll see you in a few.